Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I will go over graph transformation for trig functions. Okay, so we are going to maybe take a couple of examples. But when we say trig functions, everybody know that if I'm plotting, say, the sine or the cosine graphs. We did one where we had like tan and cotan and stuff. But anyway, let's say I have to draw a sine or a cosine, for that matter. It's the same thing. It's just a shift of 90 degrees or pi over 2. What we have here is we know that the upper limit is 1, the lower limit is -1, and the center line is 0. So there is a few things that we need to talk about. Let's say here is, say, the 0, and then maybe we have pi over 2, pi, 3 pi over 2, and 2 pi. So when I when I plot the sine curve, I start with 0 because sine 0 is 0, sine pi over 2 is 1, sine pi is 0, sine 3 pi over 2 is -1, and then sine 2 pi is 0. So I get a wave that looks something like that. It's not drawn properly, but you get the point. Now, that distance, which is between the center line and the upper or the lower limit, which is half the whole band, or this distance, we call that the amplitude. Okay, so the amplitude for this is the parent function. So when I draw y equals sine of x, or y equals cosine of x, or tan of x, or secant of x, these are called the parent functions, like we did with the other types of functions. And again, the approach I'm using is different from one you have in the book, where it says sine of a times bx plus c plus d, whatever. I don't want you to memorize these things. I want you to think how we take any function and return it back to the parent function. And what did we do in returning it? And that's exactly what happened to it. Okay. So this is the amplitude. The distance between two consecutive similar points, meaning maximum and maximum, minimum and minimum, starting point and starting point, this is the period. So one cycle is a period, and for the parent function, this is 2 pi, right? So this is pi over 2, the 0 is pi, the -1 is 3 pi over 2, and the 0 again is 2 pi. So every 2 pi, it repeats, meaning the period is 2 pi. If I do, excuse me. Now, remember we have transitions in the x or y. We have reflection over the x or the y. And we have, excuse me, guys. And we have dilation, meaning stretching or shrinking. So let's think what each one does. If I translate in the x, it means I will not start from the 0. I may start, say, at pi over 4 or -pi or what have you. We call that the difference between the 0 and where I am starting the phase shift. So x transition is called a phase shift. So these are like vocab words that we will be using. If I'm translating the y, it means my center line, instead of being 0, it's either going to be 2 or -5 or what have you. Okay, so that's the transition. When I talk about the reflection, well, if the y is multiplied by -1, it means I'm rotating or reflecting on the x-axis, And if it's the x that is multiplied by -1, I'm reflecting over the y-axis, exactly the same. Now, if I have stretching or shrinking of the x, it means my period, if I stretch it by a factor of 2, it would be 4 pi instead of 2 pi. And if it's like if I am going to shrink it by 1/3, so instead of 2 pi, it would be 2 pi over 3. The shrinking and stretching in the y changes the amplitude. Instead of the amplitude being 1, it may be 3 or it may be 1/2. So these are the things we are using, okay? So again, we learn about the phase shift. We learn about amplitude. We learn about period being stretch or shrink, being stretched or shrunk. And we talked about the transition, or I'm sorry, transition in the y, shifting the 0 and hence the upper and lower limits, as well as the amplitude if I stretch it or shrink it. So let's see, when we take an example, or before doing that, we can draw or have a table for x and y for my parent function. Okay, so that we can, if you want to construct a table, we can do that and then plot, or we can plot right away, as you will see. So we know that, for example, this is the sine of x. So x is 0. Let's say we know pi over 6, pi over 4, pi over 3, pi over 2, and so on. And let's stop at pi since it's going to repeat, but in the negative sign. So I have first of all, I'm sorry. We have 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. So we know this is 0, this is 1/2, this is √2/2, this is √3/2. We are not going to use those since they are fractional. So maybe pi over 6, pi over 2, 5 pi over 6, and pi, okay? This is 1, and then we go back, same thing, √2/2, 1/2, and 0, okay? And then when you go in the third and fourth quadrant, that would be the exact opposite when they will be negatives. And then, of course, the cosine, we start with 1. So you write those backwards here, and then they would be negative then. So let's take a couple of examples and see how we are going to do or solve these problems. Here is the first one. We want to, you tell me what happened to the parent function. Notice we work backwards. So we say what brings me back to the parent is what got me here, right? Since the parent function is y equals sine of x, so I only want the sine portion to be on the right-hand side. So I will say, okay, here is sine of x over 2 minus pi over 12. Everything else moved to the other side. So that would be y minus 2, and I subtract 2 from both sides, and then I divide both sides by 3. That's exactly what I have. And then I'm going to ask myself, how do I get from here to x, and how do I get from here to y? Think about it. I see people doing two different things, and that's fine. Because when I look at sine x over 2 minus pi over 2, minus pi over 12, some people would say, okay, let's add pi over 12, meaning have a phase shift, move to the right, pi over 12, and then multiply by 2, meaning stretch the period into 2. So instead of 2 pi, it becomes 4 pi. And someone else would say, no, I don't like that. I'm going to factor out the 1/2 and write this. So that's another way to do it. Think about, both are correct, by the way, guys. You don't have to follow exactly what the book tells you, because there are many ways of doing that. So I can say sine of 1/2 times, when I factor 1/2, I get x minus pi over 6. So if I want to go from this to x, I will stretch first and then move to the right pi over 6. So you either move to the right only pi over 12 and then stretch by a factor of 2, or stretch by a factor of 2, but in this case, you don't need to move. You have to move by double the amount, pi over 6 instead of pi over 12. Do you see that there are many ways, two different ways of finding the same transformations that produce exactly the same graph? So let's say we are going to use the second one, since this is the one you are used to. So I'm going to say for the x, I'm going to multiply by 2, meaning stretch by a factor of 2, meaning the period would be 4 pi instead of 2 pi. Okay? Easy. The period was 2 pi. I'm going to stretch it to make it 4 pi. And then what do I do? Now I have x minus pi over 6. To make it x, I will add pi over 6, meaning have a phase angle of positive pi over 6. And I'm done with the x. See how easy it is. Then I'm going to move to the y. Of course, I have to multiply by 3. No, I see someone else would say, but can I, just for the sake of, like being different, I'm going to write this as y over 3 minus 2/3. Yeah. So I'm going to add 2/3, meaning I'm going to move the center line up by a factor of 2/3. And then I'm going to stretch by a factor of 3. Yeah, but it's harder, but it's correct. Here, common sense would say multiply by 3, meaning stretch by a factor of 3, meaning the amplitude would be 3 instead of 1, because the amplitude here was 1, but if I'm going to stretch it by a factor of 3, and then I'm going to add 2, meaning move center line to 2 instead of 0. And I'm done. Nothing else. So now, in order to draw it, I can create the table. I don't need to, but we can do that. I'm going to create, just graph it, and then say, okay, what if I wanted to create a table? How would it go? Notice that the center line here is 2. And the amplitude is 3. So I add 3 to go to 5. And subtract 3 to go to negative 1. So this is negative 1. This is 5. Then the starting point, notice that my period is 4 pi, but I start at pi over 6. It's not 0. We start at 0, but if I have a phase shift of positive pi over 6, it means this point is pi over 6. And since the period is 4 pi, I can add 4 pi to pi over 6. 4 pi is 24 over 6, plus pi over 6 is 25 pi over 6. The midpoint would be the average of pi and 25, which is 26 over 2. So it would be 13 pi over 6. The average of those, 14 over 2, is 7 pi over 6. And the average of these two, these are 38 over 2, is 19 pi over 6. And then I'm going to replicate that, but it's like I'm increasing the amplitude or stretching it by a factor of 3. So at this point, I go here, and then I return back to 0, and then I go here, and then return back to 0, and it's going to look something similar, not identical to that. And I'm done. Very simple. I don't need to memorize, oh, A was the amplitude and B was the, I have to divide 2 pi by whatever, and then the C and the D and the E. And after a couple of years, I would forget which was the B and which one. No, don't memorize. Understand how to easily, algebraically move things around, and you got it. Now, if I wanted to do a table, if you wanted to construct a table for my function, see, what did I do? I started with the x. I multiplied by 2 and then added pi over 6. Multiply by 2, I get 0. Add pi over 6 is pi over 6. Multiply by 2 is pi over 3. Add pi over 6, it becomes pi over 2, right? Because pi, do you know how to add third and sixth and stuff like that? Okay. If you learn how to read a watch, it's much easier. Anyway, let's not do that. I'm sorry. So when I multiply by 2, I get 1/3. Yeah, 1/3, and then I'm going to add 1/6. So this would be pi over 2. In fact, I don't care about those because, well, maybe pi over 2. But these, with radical, I don't know how to do that. So let's go to pi over 2. When I multiply it by 2, it becomes pi. And then I'm going to add pi over 6. It would be 5 pi over 6. Why did I do that? What did we do? The x again, multiplied by 2. And add pi over 6. So shouldn't I? So when I have, forget about the pi over 6. So when I have that, I should get 7 pi over 6, right? Yeah. When I multiply by 2, I get pi, and then pi is 6 pi over 6. So when I add pi over 6, I get 7 pi over 6. And then when I go to the pi, multiply by 2, I get 2 pi, which is 12 over 6, plus pi over 6 is 13 pi over 6, and so on and so forth. When I go to the y, I multiply by 3 and then add 2. Multiply by 3, the 0 stays 0, plus 2 is 2. Multiply by 3 is 3, and add 2 is 5. Multiply by 3, it's still 0, and then you get 2. So you can see pi over 6 is 2, 7 pi over 6 is 5, 13 pi over 6 is 2, and you can create a table which you don't really need. Also, we can use the calculator. Just I want to make sure. Yeah, we are in radians and function. Okay. So let's go to y and say y equals 3 sine x over 2 minus pi over 12 plus 2. And then for the window, I go slightly below -1, so maybe -2. Oh, I'm sorry, that's the y, that's the x. So let's start from 0, oops, 0, and go to, say, 5 pi. And then for the y, I need to go from, say, -2 to 6. And then graph it. So you go from 5 to -1, but you can look at the table, or better even, you go to calc and get a value, say at 7 pi over 6 and 19 pi over 6. So if I go to the value, I say 7 pi over 6, and it tells you the y is 5. And if I go back and make it 19 pi over 6, I should get -1. -1. So that's how we do it. Very simple. If I want the cosine, so x, y, and this is cosine of x. I know that x is 0, y is 1, x is pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, you go back to 1. So that's the parent function. The second, because the second example tells you, here is the equation we want to work with. So my parent function is y equals cos x. And I'm going to see how do I make this equals just the cosine on the right-hand side. So on the right-hand side, I will add 4 to both sides and then divide both sides by 2. So that would give me cos pi over 6 x minus 15. That's it. So let's see what happens for the x. In order to make this whole thing x, I have to multiply by 6 over pi. 6 over pi meaning stretch by a factor 6 over pi. It was 2 pi. So when I multiply it, you see, here I multiplied by 2, so the 2 pi became 4 pi. Here I'm going to multiply by 6 over pi. So 2 pi times 6 over pi, the pi's cancel, and 2 times 6 would be 12. So the period would be 12. Then I'm going to add 15, because now add 15, so the phase angle, it would be 15. So I start from 15. 15 would be at 1, or not 1, the maximum, and then it moves. And that's it. Now, when I move to the y, I'm going to multiply by 2, meaning stretch by a factor of 2, meaning the amplitude would be 2 instead of 1. And then subtract 4, meaning move the center, move the whole thing. But basically what we are interested in is the center line 4 units down. Done. If I want to construct a table, where is the page? So if I want to construct the table, x and y for my function, for the x, I multiplied by 6 over pi, so it stays 0. And then I added 15, so that x is 15. Pi over 2, I multiply by 6 over pi, that becomes 3. And then I added 12, and then I added 15, so it becomes 18. Pi, you multiply by 6 over pi, it becomes 6 plus 15. I keep reading that this is 12. No, that's the 12 is the total period. Okay, 3 pi over 2, you multiply by 6 over pi, you get 9, right? And then you add 15, that is 24. And then 2 pi by 6 over pi becomes 12, plus 15 is 27. These are the x's. That's if you want to plot or to construct a table, or you are asked to construct a table. For the y, I'm going to multiply by 2 and subtract 4. Multiply by 2 is 2, subtract 4 is -2. Multiply by 2 is 0, subtract 4 is -4. Multiply by 2 is -2. Subtract 4 is -6. Multiply by 2, subtract 2, so it's -4 and -2. Okay? However, you don't need that because you already know everything you want. I'm going to say, without constructing any table, I'm going to draw a center line a max and a min, or an upper and a lower. So the first thing I say is that the center line is at -4, right? And the amplitude is 2. So you add 2 to -2 and subtract 2 to -6. I'm not starting from 0. I'm starting at the phase shift. And the phase angle or the phase shift is 15. So it's 15. And the period is 12. So I go from 15 to 27. That's a whole period. The midpoint is the average between these two, which is 21, right? And then the average of these two is midway, which is 18, and the average of these two is midway, which is 24. I know that I start maximum at the cosine, then I go to the 0, then I go to minimum, then I go to 0, then I go to maximum again. So it's going to look something like that. And like we did before, we can go back and plot that on the calculator. So this becomes 2 cos pi over 6, open a new parentheses, x minus 15, close both parentheses and subtract 4. For the window, my x should start, say, at 12 or 13, ends maybe at 30. The y, we had -6, so I'm going to start from -7, and the maximum was -2, so let's say 0. That's basically what we have, okay? I can go to the calc and pick few values. So when x is, say, 15, that's easy. You get -2. At 15, you get -2. Okay, another one. Let's say at 24, I should get -4. Yes, -4. And maybe one else, another one, maybe what, 21, I should get 0. Oh, I'm sorry, at 21, I get -6. Why did I say 0? Where did I get the 0 from? Anyway, but you can see, I really don't need to memorize what does A and B and C and D stand for, or why do we say, why do I divide by 2 pi or whatever? No, it just use simple algebra and see how do I return this thing. Left-hand side, I want to make it y. The right-hand side, I want to make it sine x. And that's it, because that's the parent function. And if you are adding or subtracting, that's translation. If you multiply or divide, that's dilation. And if we didn't have an example, I'm sorry, if I should have made this pi over 12 minus x over 2. So because you would multiply the x by -1, which means you are rotating about the y axis. So you will take this graph and turn it backwards. So it's going to look something like that. It's so easy. But I hope this was easy for you to follow. If you have any questions or comments, please don't hesitate to let me know. And I'll try to get back to you as soon as I can. Thank you very much for your time. Hope to see you soon.